Alright, hey guys. Yeah, you've already noticed I'm not here. There's been a change in my situation. I'm not going to be around for the next couple of days, but I'm just going to catch you up on what we've done in case you forgot or you want to update your notes. I'm going to lay out the content for the week, or refresh you on the content we've done so far this week, and then in a couple of follow-up videos, I'm going to lay out the content for the week, and I'm going to also put up a quiz for Friday. It will be available from Friday until Sunday night. You guys are welcome to email me with questions. I will do my best to get back to you on these questions. And this should look fairly familiar. This is basically stuff from class. So we started this week with basic exponent properties. We went with first multiplication. When we're multiplying with the same base numbers, emphasis guys, same bases. So same base numbers, when we multiply them, we don't modify our bases at all. So we're just going to keep our bases. That was a little long. And I'm trying to write this with a mouse, not my normal drawing tablet, so you'll have to bear with me, guys. And I do this all in one take. So we keep our bases. So this is just going to straight up have a base of 11. And we would add our exponents, giving me a base of 11, exponent 10. No big deal. Easy enough. And then I would just go down the list, same bases, yup. So I keep my base. Mister, these were in our notes. I know. And we're going to do these. Like I said, I just snagged these from earlier. So 21 to the 10th times 21 to the 5th, 21 to the 15th. No big deal. This one right here, you guys can see, I would do base of 2. 13 plus 27 is 40. I will use a little more space for future problems because I see this is getting pretty crammed. And this one, I'm going to put it over here. A lot of people were oopsing today because they didn't realize or they forgot that 13 with no exponent had an exponent of 1. So our base number would have been 13 and we would have had an exponent of 6. Today the big thing we approached was that when we do division with the same base numbers, we are going to subtract our exponents. Makes sense. Think about it, guys. When we multiplied up here, multiplication, we added exponents. The opposite of multiplication is division. So we do the opposite of addition, we subtract. So like this first problem would have been 39 to the 18 minus 14 is 4, or 39 to the 4th power. This 4 down here, 4 is the base for both of these, so I know this can happen. Keep my base of 4. 22 minus 13 is a 9, so I simply have 4 to the 9th. This one, negative 9 in parentheses. Yes, there's alternate ways of expressing this, but this is the base, so I'm just going to leave it alone and keep my base, negative 9. And then I'm just going to do 12 minus 8 is 4. Cool, done. This last one brought about the big thing we were looking at the end of class today on Tuesday. So 13 to the 5th divided by 13 to the 9th. We keep our base of 13. 5 minus 9? Well, 5 minus 9 is going to give me a negative 4. So this brings us to a negative exponent can exist. Once we started subtracting, a negative was kind of inevitable. So my big question of the day for people was, if a negative exponent, or if a negative is the opposite of a positive. So think about it, guys. Negatives, positives, they're opposites. Positive exponents are repeated multiplication. So we think the opposite. What is the opposite of repeated multiplication? Well, there's no opposite to repeated, really, so we're going to keep repeated. But the opposite of multiplication is division. So a opposite of repeated multiplication would simply be, oh, sorry, I was trying to be fancy. Hang on a second. So down here, my opposite of a negative exponent is going to be repeated division. So that's the opposite of repeated multiplication. So a negative exponent is repeated division. Now guys, I made a point of being silly with this in most of our classes today. I can't overstate this, guys. A negative exponent has no effect on the answer. The negative exponent means we're dividing. So if I have a positive base, I'm still going to have a positive answer. If I have a negative base, we're going to be doing our math out appropriately, and I could have either a negative base or a negative answer or a positive answer. Either one's possible when it's a negative base. It has nothing to do with the exponent. So I can't overstate that. So like if up above you were looking at it and you went, hey, I saw that 13 to the negative 4. And you went, okay, so that obviously means I'm going to have like negative 13 to the 4th. Yeah, no, that is not a thing. Don't go there at all. So how do we write this repeated division? Well, okay. This was sized for a different computer screen. This is the downside of doing it in one take, guys. You can see it's already on screen. Rather than trying to write something funky, we just go, hey, fractions are division. So my repeated division, so 5 to the negative 3rd, would be written right like we have here. 5 to the negative 3rd would become a 1 over 5 to the 3rd. I just pop it straight into the denominator of a fraction. I cannot stress enough, guys, that it's just the thing with the negative exponent that moves. This will be more relevant later on. But for now, 1 over 5 to the negative 3 becomes 1 over 5 to the 3rd. This is an example we did most of us in class, and most of you saw me fix the typo, and we're going to fix it one last time. Oop, there we go. If you think about it, it does make sense though. Guys, walk it through with me. If I have 500 and I divide it by 5 3 times, 500 over 5, well, that's a 100. 100 over 5, second time of dividing it by 5. That's going to get me a 20. And last but not least, 20 over 5. This is going to get me a 4. Now, let's look at it a slightly different way. So changing gears, I'm going to look at it over here. I'm going to treat it like a multiplication problem. So PEMDAS, parentheses, no parentheses, moving on. Exponents. I have that 5 to the negative 3. So the first thing I'm going to do is make this into a 500 times, sorry guys, I'm writing with a mouse. That 5 to the negative 3, I am going to convert it to a fraction. 1 over 5 to the 3rd. Then I'm going to go, okay, exponents. Is there more I should do here? Yes. This is an exponent smaller than 4, so I'm expecting you guys to use it. So I'd go, okay, this is really 500 times 1 over 125. Cool, great. This gives us 500, for example, sorry, I'm going to put the 500 over 1, and I'm going to go, okay, 500 times 1 is 500. 1 times 125 is 125. 500 over 125, you guys can take a moment, figure it out, and you're going to get 4. Same time, I got the same answers in both places. So by converting it into a fraction, we make it like division. So that's kind of it. So down here, we had these 3 problems. Most of my classes today on Tuesday did it. Not all of us did. But what you're expected to do is just take this and turn it to a fraction with a positive exponent. So boom, I'm going to turn it into 1 over 39 to the 5th. My negative was telling me that we are doing the opposite of what we were. So this, instead of being repeated multiplication, became repeated division. So 1 over 39 to the 5th. As per the usual directions, guys, I am not making you use 39 to the 5th. We're going to leave it alone. So 12 to the negative 7. And guys, pause me at any point, do it yourself. But I'm going to go, okay, 1 over 12 was still my base number, so that's still what I have. Negative 7 now just becomes a 7. That's it. And last but not least, yes, I'm changing colors again. Wahoo. Negative 17 in parentheses is my base. I'm going to leave it alone, put it in my denominator. I'm going to put a 1 in my numerator. Oop, that's a bigger one than I like. Boop. And then I have that exponent of negative 12. Well, I changed it to division, so I'm just going to bring along my 12, and it's now positive, it's happy, it's good with life. This is where we got to today, or this week so far. I'm going to end this video. I'm going to start up another one. You will still see the same clutter in the background. For me, it's going to be a literal 2-minute thing.